or a computer. Okay. And this wafer has to be manufactured or fabricated in a factory. Okay. In our country, we no longer has a factory to do this. Therefore, after you design using software to design a chip, once you want to implement to get a real chip, you have to send it overseas to do that, to do fabrication to get a real chip. A person that you should know is, his name is Gordon Moore. Mr. Moore is a chairman of Intel Corporation. He said his statement in 1970 is that the digital circuit technology has been rapidly changed such that the number of transistors in a single chip increases, is double every 1.5 or 2 years. Okay, within this period. Okay. Like in a same chips area, you can put like double the number of the transistors there. So a lot of functionalities can be added, okay, in that area. And this statement is called Moore's law, because it is still true until now. So people agree about his statement. Okay, it's a famous statement. The next thing that you should know is the Semiconductor Industry Association, SIA. What it does is pretty much it takes care of the roadmap or the technology direction of how the digital design is going. Okay, it has to be in what direction, how fast, how soon, how small the chip should be. Okay, the growth of the technology. This is called SIA roadmap. Okay, it's like a government to control this technology. Okay. It also predicts the minimum size of transistor that can be put in a single chip. What is transistor? What is it? We talked about that last time, right? What is it? Remember? What? T-length? Yeah. Have you seen that in a class? You took a class using that? Okay. Yeah. Yeah. It's a smallest device. Okay. Put together to make a circuit. Okay, so in the other words, a circuit consists of multiple transistors connected in a certain way. Okay, a transistor behaves pretty much like a switch, a bistate switch. So it could either open or close, open switch or close the switch. So it produces the state 0 and 1, just like that. Okay, we are going to talk about that in detail later on. So let's see table number 1. I don't think I have it in a slide. We talked about that last time, right? Okay, just bear with me just for a moment. Just want to show you quickly. We talked about that last time of how the development of the technology is like here. Okay, so in this table there are many years listed since 1999 up to 2012, and the main differences among these years are the transistor gate length, or the size of a transistor, okay, that it is planned to be reduced by, for example, from 0.14 micron, that's micrometer, okay, to 0.035 micron technology. Okay, and therefore the size is smaller. A transistor size is smaller. In a certain area, the same area, you can put more number of transistors there. Okay, so from 14 million transistors, it could be 100 million transistors in like 13 years. So that's actually 10 years from now, right? Pretty much 2012. And the chip size could be a little bit larger than now, so that we can put more and more. So once we put like many functions in a same chip, okay, in a single chip, it is much more efficient than using multiple chips and then you just manually connect them together. Okay, in terms of speed, okay, a single chip has higher speed than multiple chips and use less space, less area of the design. Okay. And we said, I talked last time that there are like pretty much 3 main types for the chips. The first one is called standard chips. Okay, consisting of small number of transistors, less than 100 transistors, okay, has more circuits and can provide just a simple function. So in order to obtain a complicated function, you have to put many of the chips together. This type of chips is